inverse trig integrals today. So dealing with our inverse trig functions, that's the inverse sine, cosine, tangent. And then also sometimes remember these could be called like the arc sine is the same as, right, the arc sine of x is the same thing as the inverse sine of x with that -1 above the sign, right? So different notation, arc sine, arc cosine, arc tangent. Now, again, just like the other integrals, we need to understand what the derivative looks like. So quick refresher on the derivatives of our inverse trig functions, but we know the derivative of inverse sine is the 1 over the square root of 1 minus x squared. The derivative of inverse cosine is -1 over the square root of 1 minus x squared. So if you guys remember, these two are basically the same, right? They look very much alike. That brings out that -1 there. So that might be something to help you remember with it. And then the inverse tangent, the derivative of that is 1 over 1 plus x squared. So that one's a little bit different, still has the x squared, but there's no square root and there's a plus sign instead of the minus sign in between. All right, so really there's not a whole lot of craziness here. We just need to be able to recognize when we see something that looks like inverse sine, cosine, or inverse tangent. So for instance, the first one, we're just going backwards. The integral of 1 over the square root of 1 minus x squared, this is just going to be the inverse sine of x, and then we throw that plus c in there. And we have our inverse cosine if you see something with the negative up front there. And then we also have that inverse tan of x plus c. Right, so not too tricky. There's a couple practice problems down here. I'll do one with you guys, but not too many. I just want you guys to get used to these. But really, you just need to have a familiarity with those derivatives of the inverse sine, cosine, and inverse tangent functions. So in this one here, what I'm going to do first is I'm going to GCF out that 4 so we really see what we're looking at here. And if we GCF out that 4, we end up with 4 times the integral of 1 over the square root of 1 minus x squared dx. And again, this thing right here, that's your inverse sine derivative. So we know the integral of this is just going to be 4 times the inverse sine of x, and then we have that plus c at the end. Right, so the other examples are pretty similar to that. We just want to be able to identify what the derivative of those look like, so that way we know when we integrate, we'll get those inverse sine, inverse cosine, or inverse tangent functions. So take a look at some of the practice, and once you guys are ready, we can move on to our next type of integral.